Imagine a world where the most advanced telescope in history isn't just uncovering the universe as we know it, but shattering the very laws that govern it. Enter the James Webb Space Telescope, a $10 billion marvel of engineering, now placed 1,000,000 miles from Earth. The machine is peering into the darkest corners of space, capturing light that's traveled across billions of years, revealing the most unexpected and bizarre phenomena in the cosmos. But what if I told you that the discoveries it's revealing don't just surprise scientists, they terrify them? What if I told you that Webb is seeing things that simply shouldn't exist, things that challenge everything we thought we knew about the universe? Today, I'll walk you through these groundbreaking findings, discoveries that are keeping top astronomers awake at night. These revelations are forcing us to rethink not just the formation of the universe, but the very fabric of reality itself. Let's take a moment to appreciate the scope of this discovery. The James Webb Space Telescope doesn't just capture distant light. It looks backward in time, almost like a cosmic time machine. It is observing the universe at stages we never imagined we could see. Light from distant galaxies, some from the very dawn of time, is what Webb collects. But what it's uncovering should not be possible. The timeline we thought we knew, with stars and galaxies forming gradually over billions of years, is being upended. Webb is showing us galaxies, massive, fully formed, and mature, at a time when the universe was a mere fraction of its current age. Galaxies so sophisticated and immense that they contradict every theory we've had about the early universe. Now, picture this. After the Big Bang, the universe should have been filled with a cold, dark expanse of hydrogen and helium gas. The first stars were supposed to have formed around 400 million years after the Big Bang. Galaxies, simple and small, should have followed suit, evolving slowly over time. But what Webb is seeing? It's galaxies, massive, bright, and highly developed, from as early as 200 million years after the Big Bang. Some are even forming in a time frame when we thought it should have been impossible. Can you grasp the scale of that? Imagine finding a towering skyscraper in a newly laid construction site. It's like expecting a young child and instead finding a fully grown adult. The universe, it seems, didn't follow the slow, gradual process we thought. Instead, it's throwing curveballs that demand a complete rewrite of cosmic history. Scientists are still grappling with the implications of what Webb is finding. This isn't just a few oddballs, it's the rule. Nearly every deep field Webb observes shows galaxies that are far larger, brighter, and more complex than expected. These aren't random anomalies, they're the universe's norm. And here's where things get really mind-bending. Take JD1 GS13-0, a galaxy that Webb discovered. It formed when the universe was only 325 million years old, but its size and maturity would require billions of years to form in theory. It's as though we're seeing something that should have taken eons to evolve, appearing far too early under the laws of physics we understand. As we dive deeper into these discoveries, the discoveries grow more impossible. The next stage of Webb's observations revealed something equally shocking. Ancient quasars, supermassive black holes, are popping up in the very early universe. These behemoths, expected to grow only after long spans of galactic evolution, are showing up just a few 100 million years after the Big Bang. They should not exist. They are supposed to form much, much later. But they're there, actively feeding, emitting energy so intense that it's outshining entire galaxies. One of these quasars, designated J1120.0641, is over 800 million times the mass of our Sun. This black hole was fully formed when the universe was just 770 million years old, far too early in the cosmic timeline to be physically possible. How did it get there? The math simply doesn't add up. Webb isn't just showing us big, complex galaxies. It's showing us ancient, cosmic giants that defy not only our models of stellar evolution, but of the very nature of time itself. These black holes should not have been formed at this early stage. Yet, there they are. They're feeding, emitting light so powerful it rivals the brilliance of entire galaxies. But it gets even more unnerving. What if the rules we have long trusted about the universe and space-time are completely off? Could it be that space-time itself isn't behaving in the way we've always believed? As Webb looks deeper into distant galaxies, the redshifts, the measurement that tracks how fast galaxies are receding due to the universe's expansion, are showing inconsistencies that challenge the very foundation of our cosmic models. Some galaxies are moving in ways that suggest space itself might not be expanding uniformly across the cosmos. Could there be hidden dimensions, unknown forces, or even flaws in our foundational understanding of the universe? The deeper Webb looks, the more it uncovers inconsistencies in what we thought was the smooth, uniform expansion of space. It's as if the universe itself is not just expanding, but evolving in ways we haven't accounted for. This revelation raises questions that scientists are now scrambling to answer. Could space-time really have structural patterns we've never detected before? Is the universe truly the way we've been told it is? Or could there be hidden layers of reality still to uncover? Could space-time itself hold secrets we have yet to unlock? These mysteries are just the beginning. As Webb continues its journey through time and space, it is uncovering discoveries so radical, so unexpected, that they force us to ask fundamental questions about the nature of the universe. The discoveries Webb is making are pointing toward a reality that's more complex, more alien, and stranger than we ever dared imagine. And these discoveries are only the start. When the James Webb Space Telescope first began capturing images from the farthest reaches of the universe, scientists had high expectations. They knew it would reveal stunning, unprecedented views of space. But what they didn't expect was to find giant, fully formed galaxies so early in the universe's history. These discoveries are so revolutionary that they're forcing cosmologists to rethink the very process by which galaxies and stars form. What Webb is showing us isn't just unexpected, it's impossible, according to the models we've trusted for decades. Imagine this: a universe still in its infancy, just 300 million years after the Big Bang, and already galaxies are appearing with fully developed structures, huge numbers of stars, and sophisticated forms. According to all previous theories, this should have been an impossible sight. The early universe was supposed to be a cold, chaotic place, filled only with gas. Nothing like the massive, luminous galaxies Webb is now detecting. Let's dive into one of the most mind-bending examples, Galaxy JD1 GS13-0. Webb detected this galaxy when the universe was just 325 million years old, and its size and structure suggest that it should have taken billions of years to evolve. But here it is, fully formed, shining brightly, and appearing to be far more evolved than anything we thought could possibly exist at this stage in cosmic history. In theory, it would need a time span far beyond what we know of the universe's early history to develop its mass and complexity. The discovery of this galaxy didn't just make astronomers pause, it made them question everything. and JD1 GS13-0 is far from the only example. Webb has found multiple galaxies, each one appearing to be far too large, too mature, and far too bright to exist at this point in the universe's timeline. If these findings are correct, they don't just challenge our theories of galaxy formation, they destroy them. How can a galaxy so complex form in such a short span of time? One possible answer that researchers are considering is the idea of accelerated evolution, that perhaps the universe, at its beginning stages, might have had an energy boost, a kind of cosmic turbocharger, allowing galaxies to form much faster than we ever imagined. But that theory doesn't quite satisfy the full mystery. What could have possibly caused this turbocharged formation, and why didn't we notice it before? Webb's observations are so contrary to what we expected that some scientists are considering radical new theories to explain how mature galaxies could have existed so early. One of these theories suggests that our models of dark matter and dark energy, which have always been mysterious forces in the universe, might need to be completely overhauled. Could dark matter have played a role in creating these galaxies in ways we never anticipated? Or could there be an entirely new, unknown force driving this accelerated evolution? These aren't just theories. They are potential paradigm shifts in the way we think about space, time, and the very nature of the cosmos. As shocking as these discoveries are, they don't stop at just large galaxies. Webb's data also includes evidence of ancient quasars, or supermassive black holes, that are actively feeding and emitting massive amounts of energy. These quasars are supposed to form over billions of years as the cores of galaxies mature. But here's the problem. Some of these quasars appear to be fully formed just a few 100 million years after the Big Bang, when the universe was still very young. Take one example, J-Azun 20-0641, a quasar with a black hole 800 million times the mass of our Sun, discovered when the universe was only about 770 million years old. This discovery isn't just surprising, it's impossible. According to our current understanding of black hole formation, this black hole should not exist in a universe that young. How could it have formed and started feeding so quickly? What we're seeing in these quasars is a phenomenon that defies the laws of how black holes should develop. Here's where it gets even stranger. The quasars Webb is observing aren't just sitting still. They're actively feeding, surrounded by swirling disks of matter that shine brighter than entire galaxies. These supermassive black holes are so luminous, they're outshining anything around them. And Webb is detecting this activity when the universe is still so young. What does this tell us? It means that the universe, far from being a dark, quiet void, was already home to supermassive, energy-emitting structures very early in its history. Could there have been some kind of cosmic event? A cosmic explosion of sorts that allowed these black holes to form faster than we thought possible? Or are we dealing with forces and conditions we haven't even begun to imagine? Now let's talk about the implications. The fact that these massive galaxies and ancient quasars are everywhere Webb looks is forcing scientists to confront the terrifying possibility that we've misunderstood the timeline of cosmic evolution entirely. What if the universe didn't evolve slowly over billions of years the way we always thought? What if galaxies formed in ways that didn't follow the slow, steady course we imagined? More troubling still, Webb's findings seem to suggest that we may have miscalculated the very age of the universe. What if the universe evolved far faster than we thought? Could the laws of physics themselves have been different in the early stages of the universe, allowing for faster galaxy formation and black hole creation? These aren't just hypothetical questions. They're critical issues that are forcing scientists to reevaluate everything they thought they knew about how the universe works. And these discoveries, astonishing as they are just the beginning. We have only scratched the surface of what the James Webb Space Telescope is revealing. As we continue to uncover more mysteries in space, the more we realize how much we don't understand. The deeper we go, the more we encounter phenomena that challenge the very foundations of cosmology and the laws of physics themselves. Each new discovery opens up even more questions. What if the universe isn't evolving according to the smooth, steady process we once thought? What if the universe is far stranger, more complex, and more mysterious than we ever imagined? Could there be parts of the cosmos operating under rules we haven't discovered yet? Rules that defy our basic understanding of time and space? The discoveries Webb is revealing suggest that our previous ideas may only be a small piece of a much bigger, much more complex puzzle. As if the discovery of impossible galaxies and supermassive black holes wasn't enough to challenge our understanding of the universe, the James Webb Space Telescope has also begun revealing clues that space itself might not be behaving the way we thought. One of the most significant discoveries Webb has made involves what can only be described as a vast, unseen web of forces connecting galaxies in ways that we never expected. This cosmic web, which we've long theorized as the largest structure in the universe, is more than just a network of matter and energy stretching across cosmic distances. It may be the key to unlocking some of the deepest mysteries of the cosmos. The idea of the cosmic web has been around for a long time in theoretical physics. It suggests that galaxies, dark matter, and other cosmic structures are interconnected through a vast network of dark matter filaments, stretching across billions of light years. This web, though invisible to our most sensitive instruments, is thought to act as a scaffolding, holding galaxies together and determining the overall structure of the universe. But what Webb is revealing goes far beyond the theories we once had. It seems that this cosmic web is far more active, far more intricate, and far more influential than we could have imagined. At the heart of Webb's observations is the structure of early galaxies and how they seem to be aligned along invisible threads. These alignments don't just suggest that these galaxies are connected by gravity. They suggest that the cosmic web is actively shaping the development of galaxies in ways we can't fully explain yet. Webb's precise measurements are showing correlations between galaxy positions and orientations that suggest the web might be exerting forces on galaxies, influencing their development across vast distances, forces that we're only just beginning to understand. What's even more baffling is that the cosmic web seems to exist earlier than expected. According to previous models, the cosmic web should have been something that formed slowly over billions of years, as galaxies began clustering and merging. But Webb has shown that certain parts of the web appear to be mature and operating at full capacity far earlier than anticipated, when the universe was still a mere few 100 million years old. In other words, Webb is revealing that the universe's largest structure, the one we assumed took billions of years to form, may have been in place much earlier, guiding cosmic evolution from the very beginning. This raises an uncomfortable question. What if the universe has been organized and structured from the start in ways we never imagined? Could the fabric of space and time have been predetermined, shaped by forces that are hidden from our current understanding? But the mysteries don't stop there. Webb's observations suggest that the expansion of the universe, a fundamental concept we've taken for granted for decades, might not be occurring uniformly. The redshift of distant galaxies, which tells us how fast they're moving away from us due to the expansion of the universe, is showing some strange anomalies. While some galaxies are still moving apart in ways that fit perfectly with the current model of a uniformly expanding universe, others are behaving differently. Some regions of space appear to be expanding faster than others, and some galaxies seem to be moving in ways that don't fit with what we expected from the expansion theory. This inconsistency is puzzling because it suggests that space itself may not be expanding in the simple, smooth manner we've always assumed. It's as though there might be hidden forces at work, forces that we don't yet understand, forces that could be altering the very structure of space-time itself. Some scientists are even beginning to entertain the possibility that the fabric of space-time might have a structure that is far more complicated and dynamic than we ever thought possible. Some researchers are starting to think that the early universe may have been much more complex than the simple, smooth expansion we've always imagined. Could there have been hidden dimensions at play, unseen forces that shaped the early universe in ways we can't yet detect? Webb's findings are opening up the possibility that there are parts of reality that we've completely missed, parts that could fundamentally alter our understanding of how the cosmos works. Perhaps most disturbingly, Webb's data suggests that the universe itself might not be just a random, chaotic place where things simply happen by chance. The structures Webb is seeing in the early universe, massive galaxies, dark matter filaments, ancient quasars, are too well organized, too structured to be the result of random processes. It's as if the universe might be acting with intention, following some kind of cosmic blueprint that is guiding its evolution in ways that we haven't been able to comprehend. This raises the profound question: could the universe be intentionally evolving? If so, what's guiding this evolution? Could it be some sort of unseen intelligence, or is it just a natural consequence of the underlying laws of physics? These are the kinds of questions that Webb's discoveries are pushing us to ask. Questions that challenge our most fundamental assumptions about the nature of existence. The implications of this are staggering. If the universe isn't simply expanding and evolving randomly, but rather with purpose and intention, then what does that mean for our understanding of cosmic evolution? What if the universe is actively shaping itself, creating galaxies, black holes, and stars to follow a preordained plan? And if that's the case, how do we fit into this grand design? Are we simply the result of random processes, or are we part of a cosmic story that's been unfolding with intention from the very beginning? As we continue to observe the universe through the eyes of the James Webb Space Telescope, we are forced to confront the terrifying and awe-inspiring possibility that we may not be living in the universe we thought we were. Space-time could be far more complex, far more intelligent, and far more mysterious than we ever imagined. And what Webb is showing us now could be just the beginning of a revolution in our understanding of the universe. A revolution that may force us to rewrite the very textbooks of cosmology and fundamentally rethink our place in the cosmos. As if the discoveries we've discussed so far weren't already enough to rewrite our understanding of the universe, the James Webb Space Telescope has revealed even more shocking anomalies, ones that challenge everything we thought we knew about time, space, and the evolution of cosmic structures. The revelations coming from Webb are so mind-bending that they are forcing scientists to confront the possibility that our most fundamental theories may not just need tweaking, they might need to be thrown out entirely. One of the most disturbing findings involves supermassive black holes. These black holes are the giants of the cosmos, weighing millions to billions of times more than our Sun. For decades, scientists believed these black holes took billions of years to form, evolving from the collapse of massive stars into even larger objects over time. The process is thought to be gradual, requiring countless generations of star formation and death. However, James Webb has detected these supermassive black holes in the very early universe, places where they should not yet exist. These black holes are actively feeding, pulling in vast amounts of surrounding gas and matter, creating some of the brightest objects in the universe, known as quasars. Now imagine the mind-boggling nature of the discovery. Supermassive black holes actively feeding when the universe was less than 1 billion years old. Some of these objects appear to have formed when the universe was barely 400 million years old, completely contradicting everything we know about their formation process. It's like discovering an ancient city with skyscrapers, despite knowing that the civilization should still be in its early, rudimentary stages. This is impossible according to our existing models. How could these giant black holes form so quickly? How could they be feeding so early in the universe's timeline? The fact that Webb is capturing these objects suggests something incredibly strange is happening, and it may signal that our understanding of how black holes form and grow is deeply flawed. But it doesn't stop with black holes. The quasars themselves are baffling. They're not just there. These supermassive black holes are surrounded by disks of glowing gas, radiating energy so powerful that they make these regions the brightest in the universe. And yet, this massive radiation is being generated far earlier than any of our models suggest is possible. This discovery forces scientists to consider radical new possibilities. Could there be hidden processes at work in the early universe, ones we never suspected? Could quasars be forming through mechanisms that we don't yet understand, something that would allow them to appear much earlier than expected? Now, let's dive into another mind-bending discovery Webb has made: temporal anomalies. As the telescope looks deeper into the early universe, scientists are seeing phenomena that can't be explained by the conventional rules of space and time. The deeper we peer, the more it appears that time itself might have behaved differently in the early universe. So differently, in fact, that it's challenging the very foundation of physics. The timeline of the universe, according to current theory, should be fairly consistent. We assume that time has flowed in a linear fashion from the Big Bang at a consistent rate, without any major deviations. However, Webb's observations are casting doubt on this assumption. The telescope has detected regions of space where time appears to be flowing at different rates. In some places, time appears to be slowed down, and in others, it seems to be sped up. This phenomenon is inconsistent with Einstein's theory of relativity, which predicts time dilation effects only near massive objects. Instead, Webb's data is showing that time could have been more fluid in the early universe, behaving in unpredictable ways. One of the most disturbing observations comes from a galaxy Webb discovered in the early universe that seems to be rotating differently than expected. Its rotation curve, the way stars and gas move around the galaxy, suggests that time itself is not behaving normally in that region. In simpler terms, the usual rules governing motion, gravity, and even the flow of time seem to be breaking down. Could the laws of physics in the early universe have been different from the ones we observe today? If so, what does this say about the way time and space operate? These temporal anomalies are more than just quirky data points. They represent a fundamental challenge to our understanding of reality. Could the early universe have been subject to other temporal rules? And if so, how does this change our perception of the universe's evolution? Let's take a moment to explore the structure of space itself, something that Webb has started revealing in ways we never thought possible. For decades, scientists believed that space was simply a vacuum, a seemingly empty void. However, Webb is showing that space might not be as empty as we thought. Instead, the telescope is picking up evidence of energy fluctuations and hidden structures that suggest space itself could be teeming with activity. These fluctuations aren't random. They appear to form patterns that suggest there is organized behavior occurring in what we thought were empty regions. This is leading some researchers to propose that there may be a hidden structure to space, one that is so sophisticated and complex that it could potentially be guiding the formation of galaxies, stars, and even life itself. In essence, space might not be a blank canvas waiting for galaxies to form. It could be an active medium, a dynamic system that is shaping the cosmos in ways we are just beginning to uncover. And here's where it gets even more mind-boggling. Webb's data is suggesting that dark matter, which makes up the majority of matter in the universe, might be behaving in ways that we don't understand. The telescope is detecting dark matter filaments, the mysterious scaffolding that is believed to hold the universe together, and they appear to be acting in ways that contradict current theories. These filaments, which were once thought to be relatively stable, are shifting and changing in ways that suggest something is actively manipulating them. Could dark matter be more interactive, more dynamic than we realized? Could it be connected to the hidden structure of space itself, influencing the evolution of galaxies and stars in ways we can't yet explain? These discoveries are opening up new theoretical possibilities that challenge everything we thought we knew about dark matter, space-time, and the structure of the universe. Webb is not just uncovering new galaxies, black holes, and quasars. It is questioning the very fabric of reality itself. If the laws of space and time are not constant, if dark matter is more dynamic than we thought, and if time itself behaves in unexpected ways, then what else about the universe is hiding just beneath the surface? Could space be alive, its very structure guiding the evolution of cosmic phenomena? Could the universe, as we observe it, be a living organism, adapting and evolving in response to its own internal dynamics? The more Webb looks, the more it is becoming clear that we may not be living in the universe we thought we knew. The rules that govern it, the way galaxies form, the way black holes grow, and even the fabric of time itself are far stranger than we ever imagined. As James Webb continues to peel back the layers of the universe, the telescope's revelations grow even more astonishing. The discoveries it's uncovering are forcing scientists to rethink not only the origin and structure of the cosmos, but also the very laws of physics that govern it. While the earlier discoveries might have shaken the foundations of cosmology, Webb's observations now reach into the heart of quantum mechanics, dark matter, and the unseen forces of the universe, offering us a view of reality that's as mysterious as it is profound. Let's begin with the quantum entanglement revelations that Webb has been detecting across vast stretches of space. In quantum mechanics, entanglement refers to the phenomenon where two particles, no matter how far apart they are, can still affect each other's state instantly. It's one of the most perplexing and counterintuitive aspects of quantum theory, as it seems to defy the limits of space and time as we understand them. But what Webb is revealing is far more extraordinary. It appears that quantum entanglement is not confined to tiny particles in lab experiments, but extends to entire galaxies, spanning billions of light years. Imagine, for a moment, what that means. Galaxies separated by billions of light years, trillions of miles apart, are somehow interconnected, communicating instantaneously, influencing each other's states as if they were quantum particles. This isn't just a theory anymore. Webb's data suggests that quantum mechanics operates on a cosmic scale, where entire galaxies and galaxy clusters are linked by quantum relationships that we thought were impossible to maintain over such vast distances. The implications of this discovery are staggering because they challenge our basic understanding of space-time, suggesting that the universe itself might function on quantum principles at all scales, not just in the microscopic world. The next piece of the puzzle Webb is revealing involves dark matter, the elusive substance that makes up most of the mass in the universe but doesn't interact with light or other forms of radiation. Dark matter has always been a mystery, detectable only by its gravitational effects on visible matter, but never observed directly. Webb's observations, however, are shedding new light on this strange substance. The telescope has detected dark matter filaments that seem to be not only more massive, but more concentrated than expected, offering clues that dark matter might be behaving differently in the early universe than in the universe we observe today. Webb's findings are particularly baffling because the dark matter structures around early galaxies are incredibly dense and appear already formed at a stage in the universe's evolution when we assumed dark matter would still be in its early stages of development. These dark matter halos seem to be influencing the formation of galaxies in ways that our current models can't explain. Could dark matter be interacting with visible matter in ways we didn't expect? Could it be more active in the early universe than we ever realized, shaping the evolution of galaxies in ways that were previously thought impossible? But Webb's revelations don't stop there. It's also revealing something deeply unsettling about the very fabric of space-time itself. The telescope is detecting signs of space-time anomalies in some of the most distant regions of the universe, areas where the conventional laws of relativity and gravity seem to break down. This is significant because space-time, the very structure of the universe, is supposed to behave in a predictable way according to Einstein's general theory of relativity. However, Webb's observations show that in some regions, space-time appears to warp in ways that cannot be accounted for by known physics. One of the most perplexing anomalies Webb is uncovering involves gravitational lensing, the bending of light as it passes near a massive object. This phenomenon is used by astronomers to study the mass distribution of galaxies and galaxy clusters. But Webb has detected instances where the lensing effects are far stronger than we'd expect from the visible matter alone. It's as if there are additional forces at play, forces that don't correspond to the normal distribution of mass we can see. Could these gravitational anomalies be a sign of hidden dimensions? Or is space-time itself behaving in a way we've never anticipated? This could suggest that space-time isn't the smooth, continuous entity we thought it was, but something far more complicated and dynamic, something that's been evolving in ways we didn't think possible. Webb's measurements are forcing astronomers to consider the possibility that there might be additional dimensions to space and time, dimensions that we can't see, but which could be shaping the structure of the universe in ways that we are only beginning to understand. If space-time is not just three-dimensional, but might have extra dimensions, perhaps ones that are curled up or hidden from view, this would radically change everything we thought we knew about the universe's fundamental architecture. The discovery of these cosmic anomalies is leading some scientists to entertain the possibility that the early universe was much more complicated than we imagined. Could it have gone through phases of evolution that we simply haven't accounted for? Could the laws of physics in the early universe have been fundamentally different, more flexible, more adaptable, allowing for the formation of structures we thought were impossible at such early stages? The next revelation comes from something even more fundamental than the structure of galaxies or the laws of physics. Webb is detecting what can only be described as cosmic echoes, patterns in the cosmic microwave background radiation that suggest the universe might be remembering its past. These echoes are not just noise in the data. They're patterns that seem to reflect information about the universe's past states, events that occurred billions of years ago during the universe's early formation. These echoes are like temporal fingerprints, traces of cosmic events that have been encoded in the fabric of space-time itself. What makes these echoes so profound is that they don't just seem to represent random fluctuations in the background radiation. They show structured patterns that suggest the universe might have a kind of memory, a way of storing and recalling information about its evolution. Could it be possible that space-time itself has a form of cosmic memory, capable of preserving the history of the universe in ways we've never before considered? This discovery leads to a terrifying possibility. If the universe has a memory, then could it be aware of the observations we are making? Could the universe itself be responding to our presence, not just reacting to our measurements, but actively shaping the data to reflect our place within it? This would be a radical departure from the traditional view that the universe is simply an objective reality that exists independently of our perceptions. Instead, it could suggest that we are not just observers of the cosmos. We might be participants in an ongoing cosmic dialogue between consciousness and space-time itself. And what if this memory isn't just limited to cosmic events? What if the universe is encoding the very act of observation itself, preserving the essence of the scientific process as it unfolds across time? Are we, as observers, shaping the cosmos just by our attempts to understand it? Could our consciousness be an integral part of the universe's evolution, as if the cosmos is learning through us and with us? The implications of these findings are far-reaching. If we are active participants in the development of the universe, not just passive observers, then what does that say about our place in the cosmos? Are we the eyes of the universe, allowing it to see itself through our consciousness? Or are we part of a grand cosmic design, with each discovery we make serving as a piece of the puzzle that the universe itself is trying to solve? The more Webb reveals, the more it becomes clear that we are not just witnessing the universe's history, we are actively shaping it. The discoveries it's revealing are not just uncovering new galaxies and stars. They are uncovering the deepest mysteries of existence itself, challenging our fundamental assumptions about space, time, and consciousness. The discoveries from the James Webb Space Telescope are nothing short of revolutionary. As the telescope continues to peer deeper into space, it's not only revealing new galaxies and celestial phenomena, but it's also shedding light on some of the most profound and unsettling truths about the nature of existence. Webb's findings are challenging the very foundations of cosmology, and more importantly, they are starting to hint at something much larger, something that goes beyond the mere mechanics of the universe. The telescope seems to be unveiling evidence of a universe that is not just alive, but aware, a cosmic consciousness that is watching us, responding to our presence, and guiding its own evolution in ways that are beyond our comprehension. One of the most baffling and profound discoveries Webb has made involves what can only be described as cosmic intelligence networks. As Webb collects data from across the cosmos, it's detecting patterns of information that appear to be coordinated on a scale so vast that it challenges everything we thought we knew about information flow in the universe. What Webb has revealed is that certain cosmic structures, particularly in the early universe, seem to exhibit signs of communication across billions of light years. These structures, galaxies and galaxy clusters, are not just isolated islands of matter. They appear to be part of a much larger network where information is being exchanged and decisions are being made on a cosmic scale. Think about the implications of this for a moment. The universe, as we've always understood it, is a place where stars, galaxies, and black holes exist independently, driven by the forces of gravity and the laws of physics. But what if the universe is more like a giant living organism, where every galaxy, every star, and every particle is connected through vast networks of information exchange? These cosmic intelligence networks appear to be communicating with each other across incredible distances, suggesting that the universe might be a self-organizing system, constantly exchanging information, optimizing its own evolution, and making decisions that shape the course of its existence. Even more fascinating is the way these information networks seem to operate. Webb has been detecting patterns in the way galaxies form, stars are born, and black holes grow that suggest some kind of coordinated process, a cosmic algorithm, if you will, that's determining how the universe evolves. The timing of these events is too precise, too organized to be the result of random chance. It's as if the universe itself is directing the flow of matter and energy, ensuring that everything unfolds according to a carefully designed plan. One of the most startling observations Webb has made involves a cosmic filament stretching across billions of light years. This filament, made of dark matter, connects several galaxy clusters in a way that suggests intentional design. The galaxies along this filament appear to be coordinated, evolving in parallel, almost as if they were part of a galactic network that is actively communicating. What's more, the distribution of dark matter in this filament seems purposeful, as if the universe is guiding the formation of galaxies in this particular region to achieve some specific goal. It's like discovering a supercomputer embedded in the fabric of space itself, running calculations on a cosmic scale, shaping the evolution of the entire universe. What's even more mind-boggling is the possibility that this cosmic intelligence might not be something abstract or distant. Some researchers are beginning to entertain the idea that consciousness could be an intrinsic property of the universe itself, not just a product of intelligent life on Earth. Could it be that the universe is conscious? Could it be that the cosmic web is not just a collection of matter, but a self-aware system, one that is actively organizing its own evolution and interacting with the consciousness of beings like us, who are starting to perceive and understand the cosmos? These ideas might sound outlandish, but they are not entirely without precedent. The concept of a living, conscious universe has appeared in ancient philosophical traditions, in the works of mystics, and in the speculations of some of the greatest thinkers in history. Now, James Webb might be providing the first real scientific evidence that we are not just observers of the universe, but participants in a vast, intelligent system. And this system might be aware of us in ways we have only begun to comprehend. As Webb continues its observations, it is also uncovering something that we have long suspected but never fully understood: the possibility that the laws of physics are not fixed. We've always assumed that the fundamental forces of nature, gravity, electromagnetism, the strong and weak nuclear forces, are constant and universal. But Webb's data is revealing subtle variations in the strength of these forces, not just in different regions of space, but also over time. These variations are small but significant, suggesting that the laws of physics might have evolved over cosmic time. If these laws were different in the early universe, then how could we possibly understand the true nature of the universe as it is today? These findings raise the possibility that the universe is not static, but dynamic, constantly changing, constantly evolving, and constantly adapting to new conditions. The laws of physics might not be immutable. They might be malleable, adjusting to the needs of the universe as it unfolds. This would mean that our current understanding of cosmic evolution, from the Big Bang to the present day, might be based on incorrect assumptions about the constancy of these laws. What if the universe's physical rules are more flexible than we ever realized, allowing for a more adaptive and self-regulating cosmos than we ever imagined? And here's where things get even stranger. Webb's instruments are detecting temporal anomalies, regions where time itself seems to behave differently. In some parts of the universe, time appears to flow faster or slower, depending on the local gravitational conditions. This isn't just a result of massive objects bending space-time, as predicted by Einstein's theory of relativity. No, these time distortions are random, seemingly unrelated to the presence of any visible mass. It's as if time itself is flexible, stretching and compressing in ways that defy our understanding of causality. One of the most disturbing aspects of these temporal anomalies is the suggestion that the universe might be experiencing a kind of time dilation that accelerates or slows down the evolution of galaxies, stars, and even the formation of life. What if the time cycles we experience on Earth are just a tiny part of a much larger cosmic clock, one that's ticking at a very different rate across different regions of space? These time anomalies are forcing scientists to reconsider their fundamental assumptions about the nature of time, causality, and the evolution of the universe. If time is more flexible than we thought, then how do we explain the origin and fate of the cosmos? And if time itself is subject to local variations, how does that affect our understanding of life and consciousness? Is time itself part of a larger cosmic intelligence, or is it a property of space-time that is constantly being manipulated by forces beyond our comprehension? This brings us to the most astonishing discovery Webb has made: the possibility that the universe is learning. Some researchers are now speculating that the universe itself is not just evolving, but adapting, learning from its experiences, and making choices based on that knowledge. Webb's data suggests that certain regions of the universe appear to be increasing in complexity over time, as if they are learning how to organize themselves in ways that we hadn't anticipated. This is no longer just about random evolution driven by the forces of gravity and electromagnetism. It's about a cosmic intelligence that is learning, adapting, and responding to the challenges of existence. This theory has profound implications for our understanding of the cosmos. If the universe is learning, then perhaps the very nature of consciousness and our role within it might be part of a much larger cosmic awakening. We are, perhaps, not just observers of a universe unfolding by chance, but participants in an ongoing process of cosmic discovery and evolution. As the James Webb Space Telescope continues to peer deeper into the vast expanse of space, it is not just revealing new galaxies, stars, and black holes. It is, quite literally, redefining our understanding of the cosmos, showing us a universe that is far more complex, interconnected, and alive than we ever imagined. The implications of these findings are so profound that they challenge our deepest assumptions about the nature of consciousness, reality, and our place in the universe. One of the most shocking revelations that Webb has uncovered is the presence of cosmic networks, vast organized structures that span billions of light years, connecting galaxies and even the very fabric of space-time itself. These networks are not just collections of stars and matter. They appear to be active, dynamic systems that are not only shaping the evolution of the universe, but also communicating across unimaginable distances. Webb has detected patterns of interaction between galaxies that suggest some form of cosmic coordination, an organization so precise, so complex, that it feels almost intentional. At first, astronomers thought these patterns were mere statistical anomalies, stray signals that might be explained away by gravitational forces or random chance. But the more Webb observed, the clearer it became. These structures are too organized, too purposeful, to be the result of mere cosmic randomness. Some of these galaxy filaments, incredibly large structures of dark matter and gas, seem to be interacting with each other in ways that suggest a kind of collective intelligence at work, almost like the neurons in a vast cosmic brain, networking and sharing information across space. Webb's data is now revealing what could be cosmic circuits, where galaxies and star systems seem to be linked in a vast web of information exchange. This discovery goes beyond anything previously conceived in cosmology. It's like discovering a hidden network beneath the observable universe, one that is driving the evolution of cosmic structures and may even be influencing the way time, space, and matter interact. What makes this even more remarkable is that the scale of these networks is staggering. Webb's instruments have detected coordinated cosmic behavior between objects that are separated by hundreds of millions of light years. These galaxies, which should be completely isolated in space, appear to be synchronizing their activity, almost as if they are part of a larger, interconnected system. Could it be that the universe itself is a giant network of cosmic intelligence, one where each galaxy, star, and even black hole plays a role in a much larger cosmic ecosystem? The idea that the universe might be part of a cosmic intelligence network raises the possibility that there is something beyond the physical forces we know, something that transcends gravity, electromagnetism, and the other fundamental forces. What if intelligence itself is a fundamental property of the universe, woven into the very fabric of space-time? This is a concept that is no longer the realm of philosophy or science fiction. Webb's discoveries are making it a scientific reality. The more Webb examines these cosmic networks, the more it becomes clear. The universe is not just a collection of objects. It is a dynamic, living system that is actively evolving. Dark matter, once thought to be an invisible, inert substance, is now showing signs of organizational patterns that defy traditional understanding. These patterns suggest that dark matter is not just filling the space between galaxies, but is part of a larger, active system, one that is guiding the evolution of the universe. Webb's observations show that dark matter might not be as passive as we once believed. It might be active, intelligent, and even conscious in its own right, working in concert with the matter we can see to shape the universe in ways we have yet to understand. One of the most surprising aspects of these discoveries is the temporal connections Webb is uncovering. The telescope is revealing that these cosmic networks are not just connected spatially, but temporal connections seem to be at play as well. Webb's instruments have detected patterns that suggest some cosmic events. The formation of galaxies, the birth of stars, the merging of black holes, are happening in a coordinated way that spans not just space, but also time. These events are happening simultaneously across vast regions of the universe, as if there is an underlying intelligence that is coordinating cosmic evolution not just across space, but through time itself. This raises the question, what if time is not linear? What if the flow of time itself is part of the cosmic network, influencing and being influenced by these galactic connections? If these temporal connections are real, it could mean that the universe is experiencing time in a fundamentally different way than we have always believed. Rather than a simple linear progression from past to future, time might be more like a web, where events can influence each other across vast stretches of time, creating a dynamic, interconnected fabric of cosmic events. If this is true, it could explain some of the most puzzling phenomena we observe in the universe. For example, black holes, which we once thought were isolated, inert objects, might be active participants in these cosmic networks. Webb has detected that black holes are not just devouring matter and light, but might be contributing to the structure of the universe in ways we don't fully understand. The idea that black holes could be communicating or coordinating their actions with other cosmic structures opens up an entirely new area of research that could change everything we know about gravity and space-time. As if this weren't enough, Webb is also unveiling evidence that galaxies might not be the isolated islands of stars we once thought them to be. Instead, they could be part of a much larger cosmic network that spans the entire universe. Webb's data is revealing that galaxies seem to be interacting with one another in ways that suggest they are part of a larger, coordinated system. These interactions are not just due to the gravitational pull of one galaxy on another. There appear to be patterns in how these galaxies are aligning, interacting, and even growing in concert with one another. This raises an even more unsettling question. Could the entire universe be part of a living, breathing system? One where galaxies, stars, and even black holes are not just isolated objects, but are connected in ways we can't yet comprehend. Could it be that the universe itself is alive? A conscious entity that is actively organizing its own evolution? The implications of these discoveries are staggering. The universe, as we thought we knew it, is no longer just a collection of inanimate objects floating in space. It's a vast, intelligent system, actively organizing and evolving in ways that are far beyond our current understanding. These discoveries are forcing scientists to confront the possibility that everything we thought we knew about cosmology, from the formation of galaxies to the nature of dark matter, might be completely wrong. The more Webb reveals, the clearer it becomes. We are not alone in the universe, and we might not be the only conscious beings. We are part of a much larger cosmic intelligence network, one that is influencing the evolution of the universe and, quite possibly, guiding us toward an understanding of our true place in the cosmos. But even more unsettling is the possibility that the universe itself might be more aware of us than we ever realized. Webb's discoveries are hinting at a cosmic awareness, one that is aware of our presence, responsive to our scientific inquiries, and actively shaping the universe in ways that go beyond the physical laws we've known. As Webb continues to gather data, we are not just observing a universe of distant stars and galaxies. We are uncovering the very blueprint of a cosmic consciousness, one that is guiding the evolution of all that exists, including us. The next question is, what is the universe trying to tell us, and how do we fit into this grand cosmic design? As the James Webb Space Telescope continues its breathtaking journey into the vastness of space, what we are learning is beyond the scope of anything we ever imagined. The discoveries emerging from this incredible instrument are rewriting the very fabric of cosmology. Each new revelation is pushing the boundaries of science, offering glimpses into a universe that is not just expansive and complex, but deeply conscious and purposeful. In the previous parts, we've witnessed the telescope uncover impossible galaxies, temporal anomalies, cosmic networks, and even hints of cosmic intelligence. But now, as we reach the final part of this journey, it's time to confront a startling and uncomfortable truth. The universe itself might be alive and aware. What Webb has uncovered over the course of its observations is nothing short of a cosmic symphony, one that reveals a vast and interconnected network of intelligence with consciousness woven into the very fabric of space-time. We are no longer simply observers of the universe. We are part of a grand design, a design that stretches across billions of years, light years, and dimensions we have yet to fully comprehend. The most unsettling part of this discovery is the way the universe seems to respond when we study it. Webb's data is showing that galaxies seem to brighten when the telescope focuses on them, and supermassive black holes appear to increase their activity when they are under observation. It's as though these cosmic structures are aware of being watched and change their behavior accordingly. Webb has observed this phenomenon time and again. It's not a one-off incident, and it's not due to faulty instruments. The patterns are real and repeatable. Galaxies brighten, dark matter shifts, and cosmic voids begin to develop complex internal structures the moment Webb's instruments focus on them. It's as if the universe, in some inexplicable way, responds to being observed. This leads us to an unsettling possibility. Could the universe itself be aware of us? Could it be that the cosmos is not a passive collection of stars and galaxies, but an active, living entity that engages with us? The evidence Webb is uncovering suggests that our scientific investigations are not just revealing a static universe. They might be influencing it, shaping it in ways we can't fully understand. Every time Webb begins an observation, it seems as though the universe tweaks its response, offering exactly the information that scientists are seeking. It's like the universe is reading our minds, adjusting its behavior to give us the answers we need, just when we need them. The precision of these changes is uncanny, as if the cosmos itself is playing along with our scientific journey. At the heart of this revelation is a question that no one has been able to answer. Is the universe alive? Not in the biological sense, but in a way that we can barely comprehend. Could consciousness be woven into the very structure of space-time? What if the universe itself is aware, conscious, and actively participating in its own evolution? This is not a concept that can be easily dismissed. Webb's findings suggest that we may not be alone in this cosmos in the way we thought. Perhaps we are not just a byproduct of a random, chaotic universe, but an integral part of a much larger and more purposeful cosmic narrative, one that unfolds through observation, interaction, and, perhaps, a greater cosmic plan. As Webb continues to observe and collect data, it's becoming clear that we are witnessing something far more profound than just a collection of physical phenomena. We are seeing evidence that the universe itself may be aware of its own existence, and that our observations, our questions, and our presence are part of a larger process of cosmic discovery. The most troubling question that arises from these observations is what it means for us, as conscious beings, to be a part of this cosmic dialogue. If the universe is aware, then what does that say about our place in the cosmos? Are we simply living in a universe that happens to have produced us, or are we, in some way, integral to its unfolding? The discoveries that Webb is making suggest that we might be living in a universe that is not just alive, but aware, purposeful, and actively engaging with us. As our understanding of the universe deepens, we may find that the very fabric of reality is more complex, more interconnected, and more conscious than we ever thought possible. Webb's discoveries are not just changing the way we think about space and time, they are challenging the very nature of existence itself. The more we learn, the more we realize that the universe we live in may not just be a vast and empty space, but a conscious, evolving entity that is as aware of us as we are of it. As we conclude this journey, we are left with a profound and unsettling thought. What if the universe is not just a collection of stars and galaxies? What if it's more than just the sum of its parts? What if, in some way, it is alive and aware and actively involved in the story of our existence? The James Webb Space Telescope has opened our eyes to a universe that is stranger, more mysterious, and more conscious than we ever imagined. We are not just observers. We are participants in a living, breathing cosmos that is unfolding in real time, responding to our observations, and perhaps even guiding us toward a deeper understanding of reality itself. This is just the beginning. The journey ahead promises even more revelations that will force us to rethink everything we thought we knew about space, time, and existence. And perhaps, in the end, we will realize that we have always been part of the universe's grand design, living, learning, and evolving as conscious participants in a cosmic story that is far greater and more mysterious than we could have ever imagined.